So we are going to talk about projectile motion. So first of all, what is projectile motion? Whenever you hear to say projectile motion, just know to say we are talking about the motion in two dimension. When an object is moving in x direction, we call it linear motion. Okay? That is in x direction. When an object is moving in y direction, we call it free form motion. So this is free form motion, an object is in freely, this is linear motion. Now, what is happening here is that when we're talking about projectile motion, an object is moving in both x and y direction. Perhaps you have seen, maybe this is a ball, you throw it in this direction. As you can see, this object is moving in both x and y direction. Does that make sense? Does that make sense? Does that make sense? You can unmute yourself and respond.
Yes.
Okay. So when you hear to say projectile motion, we're talking about a motion in x direction and a motion in y. So we call it a two dimension. The object is moving in both x and y direction. Okay? Now, there are only three cases which you need to know under projectile motion. Okay? Quite okay. I know you know these formulas from free form motion, where you have the first formula where you have final velocity is equal to the initial velocity plus gt. Then the second one where you have d is equal to v initial times t plus half gt squared. The third one is v final squared is equal to v initial squared plus 2gd. These formulas, we use them under free form motion. Okay? The only difference which is going to be there when we're talking about the linear motion is going to be the air. Whenever we're talking about free form motion, we're talking about the object is under the influence of gravity. So where there is acceleration, we replace it with what? G. So where you see G here, whenever we're talking about linear motion, you replace it with A because you're going to have linear acceleration. Okay? Now, let me go back. We have three cases under projectile motion. We have got what we call case 1. Case 1 is a situation where you stand on top of the building, you throw a ball, then this ball is going to go down all the way up to the what? The ground. So let's say here is our building. Okay? Now you throw a ball, this ball is going to be thrown there, it goes there until it reaches down. That is the first case. What you have to understand here is that the initial velocity is going to be 0. You are going to throw this ball with the initial velocity which is going to be 0. And that is very, very important. You are going to have the height of the building, which you are going to call it h. Okay? The height of the building we are going to call it h. The height of the building is h. Then we have got what we call the horizontal distance. The horizontal distance is range. So when the question is asking about the horizontal distance, just know that we're talking about the range. Okay. Now, from here, what I want us to understand is that when an object is going up, the value of g is negative 9.8 meters per second squared. When an object is coming down, the value of g is positive 9.8 meters per second squared. But it is not always that you are going to have positive or negative 9.8 meters per second as it is going up and positive 9.8 meters per second squared as it is coming down. There are some situations where when an object is coming down, you are going to use g as negative, and I'm going to explain. Okay? Now, let's come up with a formula which is going to help us to find the h, the height of the building. Okay. Now, let's imagine to say we have the initial velocity as 0. We have the g, since it's coming down, it's going to be 9.8. What else do we have? We want to find the h, which is the same as the distance. So this h is the distance, just the distance. What else do we know? We don't know the final velocity. So these are the only things which we know for now. Okay. Now let's assume to say we have been given the time. Okay. We have the time. Which formula do you think we are going to use for us to find the height? I want you to be telling me. Let's do first for the sake of time. Which formula among those three formulas which I've given you, which formula do you think we're going to use for us to find the distance? We have the initial velocity, we don't have the final velocity. We have the g, we have been given the time. Which formula do you think is going to be best for us to use to find the distance, how high the building was?
That one which has t squared at the end.
T squared at the end. So we are going to use the formula which is going to be d is going to be equal to the v initial times t plus. Thank you. Now where there is d is the same as just putting h. We're talking about the same thing. Okay, I can put this with h. This is going to give me the v initial is 0. I can replace, if I replace this one with 0, this is going to be cancelled out. I'm going to have this. So I can see that the height of the building, it can be calculated by using this formula. So this is the first formula for the first trajectory, how high the building is. So you use this formula. Now, there are some cases where they are going to give you the velocity. Okay, I'm going to explain this later. But okay, let me just explain here. There are some cases where they are going to give you the initial velocity here. They are going to tell you to say that initial velocity is the horizontal distance, or is the horizontal velocity. That when they say the horizontal distance, they give you that initial velocity. It doesn't mean that the Vy will be also the same. The Vy, when you are throwing something from the top of the building, if they have not given you, just know that it is 0, always, unless if they give you. Okay? Now, let's find the formula which is going to help us to find the time. Okay? So to find the time, I'm going to use the same formula. Okay? We're going to assume that we know how high the building is. So we're going to say the same h will be equal to the v initial times t plus half gt squared. This is very, very important. I want you to get this. So we know that the initial velocity is 0. This is going to be cancelled out. I'm going to have h will be equal to half gt squared. My goal is to make t as a subject of formula. From here, guys, I can do times 2 everywhere to get rid of the half this side. It is the same as just saying times the reciprocal of this. I want to make t as a subject of formula. So if I do 2 times everything inside, I'm going to have 2h is going to be equal to g t squared. My goal is to make t as a subject of formula. I'm going to divide both sides by t or g, even here by g. I'll have t squared will be equal to 2h, everything divided by g. What else are we going to do? We are going to get the square root. We know that it's going to be plus or minus, but t will always be positive, so we are going to have this formula. So in this type of trajectory, to find time, this is the formula, guys. Very, very important. So our t will be equal to the square root of 2h divided by g. That is very, very, very important. So that is the second trajectory. Okay? What else do we need to know? How can you find the range? Okay? How do you find the range? To find the range, you are going to be given the velocity in x direction. That velocity in x direction, it doesn't change. The reason why the velocity will not change just because we don't have acceleration in this case. Okay? So the velocity in x direction is constant. Let me write this. The velocity in x direction is constant. The velocity is just constant. So the velocity you're going to have here is going to be the same velocity which is going to be there, same velocity which is going to be there at any point in x direction. That velocity will not change. It's going to be the same. Meaning that if I want to find the range, range is the horizontal distance. So the horizontal distance we can find it using d is equal to, distance is equal to, or let me start from speed. We start from here, we say speed is given by velocity times time. Distance over time, right? Is distance over time. So the distance which you're talking about here, the range is the horizontal. So it's the same distance which is going to be the range. So to make this d as a subject of formula, I can say that this speed is the same as the velocity. I'm going to say v is equal to d divided by t. My goal is to make d as a subject of formula. D will be equal to v times t. Now to specify which velocity are we talking about, we're talking about the vx, the velocity in x direction. So we're going to say this is going to be, this d is the same as the range. So I'm going to replace d with range. So range, the first trajectory is given by vx times t. Now this is a trajectory where you are just throwing an object. We're not using any angle here. So this formula is the one which we're going to use. So we have just come up with three formulas here. This is the formula for finding range in the first trajectory. Height is half gt squared. The time is the square root of 2h time divided by g. Do you have any question? Any question there? Yes, respond.
No. So I would like to have the what's this, the equations. I haven't seen them.
You can see the board.
No questions. No questions.
Can you see the board?
Yes, they I can, but the equations that you summarize
Oh,
at
okay.
first,
Okay,
they
okay,
were removed first, so I couldn't see them.
okay. So the first equation from the let's just review the first trajectory. We are saying that height, the height of the building, is calculated by this formula. Then the time is calculated by this formula. I want you to get this. This is very important, especially this formula. It's very, very important. We are going to use it in the third trajectory. So the third formula, we have said that the range will be given by Vx times t. Always they are going to give you this Vx, the velocity in x direction. So these are the formulas which we have just come up now. Unless you have questions. Can I go to the second trajectory?
The first equation.
You have just joined now.
Yes. Just a minute ago.
Okay, we said from this formula, d is equal to v initial times t plus half gt squared. Since you are throwing this ball from the top of the building, the initial velocity is 0, starting from rest. So this is going to be cancelled. So you have d is equal to half gt squared. Okay?
Yes, sir.
Sure. So let's go to the second one. I'm kind of asking if you can mute your mics.
Yes, sir.
I'm kind of asking if you can mute your mics. Okay, thank you. So now let's talk about the second case. So the second case, case 2, it's a situation where you throw something from the ground. It starts from here. Emmanuel, I'm kind of asking if you can just turn off your video. It's disturbing your friends. Okay, it's a situation where you throw a ball from this point, it goes there until it reaches down. Goes from there all the way down. Now what we're going to discover here is that you're going to throw this ball at an angle. That angle we call it theta. Once you reach at the maximum height, what you have to understand is that the final velocity at this point is 0, but you are going to be given the initial velocity. Meaning that this initial velocity, it is at an angle. This is the v initial. So this v initial, it has the x component and the y component. So we have got the vx and the vy. Using vectors, we can see that our vx will be equal to what? What will be vx? Come on, come on, come on, come on.
V cos theta.
V cos theta, thank you. What will be vy?
V sin theta.
V sin theta. Okay, the horizontal distance is what we are going to call the range. Now this range, what you have to understand here is this. The distance from this point all the way to the maximum height is half the whole distance. So what I'm trying to tell you now is that this is 1 over 2 range, 1 over 2 range. So this and this gives us what? The range. So if you...
I'm kindly asking if you can re-explain. I'm not understanding anything. Yeah, case two.
Okay. We are saying that case 2 is a situation where you throw a ball from the ground at an angle. Okay? So this is what we are we are from explaining. So at an angle, you are going to reach at the maximum height. This h, you are going to call it h max. Then it is at an angle. So this is theta which you have here, meaning that this velocity, once we reach at the maximum height, we know that at the maximum height, the final velocity there is 0, but you are going to be given the initial velocity, meaning that this initial velocity, it is at an angle, meaning it has got x component and the y component. So we are going to have the x component and the y component. So we have got the theta here. So this is going to be vx, vy. So using vectors to find vx, what will be vx using vectors? It's going to be vx will be equal to v cos theta. Vy is going to be v sin theta. Okay? Now, from from here, from here now, what we need to understand, guys, is that this is what we call the horizontal distance. We say that this is the range. Okay? So if this is the range, what you need to understand is that the point from the starting point all the way to the maximum height here, it is half the range. Okay? So I'm telling you to say this is the same as half range. This is also half range. Is that okay? You have gotten my point, right? Now we can start driving the formulas. Is that okay?
Yes, it's okay.
Okay, let's start now coming up with the formulas. Now, the first formula which we are going to drive here is going to be the formula for time. So let's denote this point as point A. Let me use different color. We denote this as point A, this as point B, this as point C. Now, sometimes they can ask you a question to say, at what angle are you supposed to use to project any object for you to reach the maximum range? For you to attain the maximum range, you need to use the angle which is going to be 45 degrees. Once you use 45 degrees, you are going to reach at the maximum range. Okay? That is very, very important. Once you project an object using the angle less than 45, you are not going to reach at the maximum range. If you project an object using the angle greater than 45, you're not going to reach at the maximum range. What I'm trying to say here is this. Let's assume to say we use 45 degrees. If this is our diagram here, once I use 45 degrees, I'm going to reach the maximum range. So if this is our maximum range, this is what we are going to reach somewhere there. So if this is 45 degrees, I'm going to reach at the maximum range. Once I use the angle which is going to be greater than 45, this is what is going to happen. I'm not going to reach at the maximum range. Okay? If I use the angle less than 45, still I'm not going to reach at the maximum range. I'm going to reach there. So once you hear to say they're talking about the maximum range, just know that they are talking about they are projecting that object at an angle of 45 degrees. Does that make sense? You can only reach at the maximum range if you use the angle 45 degrees. Once you go beyond 45 degrees, you're not going to have the maximum range. Once you go less than 45 degrees, you're not going to have the maximum range. That is also very, very important. Okay, now let's start now coming up with the formulas for this equation, for this trajectory. Now, we are saying that let's first use, let's see how we can come up with the formula for finding the what? The time. So let's find the time from A all the way to B. Remember, we have said that this velocity, we are going to have the velocity, the Vy to be V sine theta, the Vx to be V cos theta. Now we have this situation, guys. When an object is going up, we are using y-axis. Whenever we're talking about the range, we are using the x-axis. So to find the time in this case from A all the way to B, we are using the y-axis, meaning that we can use this formula to say V final is equal to the V initial plus GT. Now remember, we are using the Vy, so I'm going to say Vy. Here I'm going to put Vy as well. Remember, when an object is going up, the value of G is negative 9.8. So it's going to be negative in short. I'm talking about the value of G. The final velocity is going to be 0, meaning this part is going to be 0 here. Vy, according to this, what is Vy? Tell me. What will be our Vy? V sine theta. So I'm going to replace this with V sine theta plus, remember our G has to be negative times T. My goal is to find the time from this A all the way to B, meaning reaching at the maximum height. So I'm going to shift this part to the left hand side, so it's going to be negative V sine theta is going to be equal to negative GT. I'll divide both sides by negative G, both sides by negative G. The time from A all the way to B is going to be equal to V sine theta divided by G. So this is going to be the time from A all the way to B. For it to reach at the maximum height, this is going to be the formula for us to use. Unless you have questions. So the time from A all the way to B, we are saying that is V sine theta divided by G. Now, what of the time from A all the way to C? Meaning that it's going to A all the way to B. The time it's going to take from A all the way to B is going to be the same as the time it's going to take from B all the way to C. It is the same as just saying this formula which we have just come up with here times 2, meaning it's going to be how long it was in air. Is that okay? How long it was in air is the same as the time it takes for it to move from point A all the way to point C. So I'm telling you to say the time from A all the way to C is 2 V sine theta divided by G. Does that make sense? Okay. So I want you to know these formulas. This is the first one, this is the second one. Now let's see how we can find the maximum height, the formula for finding the maximum height. The formula which we can use to find the maximum height, we can use the third equation. The third equation goes like this. The final velocity, or the final V final squared is equal to V initial squared plus 2A, or is 2G. Then let me put H instead of D, which is the same as H max. I'll put H. My goal is to find the H. Remember, when an object is going up, the value of G is negative. Now, all the formulas for projectile motion, when you're plugging in the values, we have already used the negative where there is G. So you just plug in positive 9.8 meters per second in any circumstance. Because when you are driving these formulas, we are including the negative already. I hope that makes sense. Now, we are talking about the y-axis. So it's going to be Vy, even this one is going to be Vy. So the final velocity is 0. I'm going to replace this one 0 squared. Is going to be equal to, the Vy initial is going to be V sine theta, but this has to be squared. Okay? Plus 2. G is negative, so I'm going to put negative G times H. Our goal is to find the H. I'll shift this to the left hand side. I'm going to have negative V sine theta, it is squared, has to be equal to negative 2GH. Our goal is to find the H. We are going to divide both sides by negative 2G, both sides by negative 2G. So I'm going to cancel these. Okay, negative and negative will cancel. We're going to have our H max to be equal to, I can distribute this V. It's going to be V squared sine squared theta divided by G. But even if you use this direct, it's going to give you the same answer. You say V sine theta, then you square it divided by 2G. It's the same. So this is the third formula for the second trajectory. Unless you have questions. Do you have questions? Okay.
Please repeat on the second request.
Sorry.
Please repeat on the second request.
The second the second equation.
Yes, yes, sir.
Are you okay from this point here? We're talking about, we want to find the maximum height. So to find the maximum height, we do know that, you can mute your mic. We do know that we're talking about the Vy, the motion in y direction. So the final velocity at this point is 0. So I'm going to replace this one is 0 squared. This Vy is V sine theta, the initial velocity, V sine theta, but it is squared, so I'm going to square it. Plus 2, since it's going up, the G is negative, times H. I'm going to shift this to the left hand side. It's going to be negative V sine theta squared has to be equal to negative 2GH. Our goal is to find the H. I'll divide both sides by 2G, both sides by negative 2G. Now, as we can see, these two can cancel. Then negative and negative can cancel. We are now remaining with H to be equal to, I can distribute again this to put it inside. Is going to be V squared sine squared theta divided by 2G. So this is the formula. Now we don't square the theta, we only square the sine. That's the principle which is there. We don't square the angle. Is that okay?
I'm clear, sir.
Thank you.
Yes, sir.
So let's put this formula here. It's going to help us. H we are saying is V squared sine squared theta divided by 2G. Now I want us to concentrate on the range. The range. How do we find the range? Okay. So to find the range, we are going to say that the same formula, range is Vx times t. But according to what we have here, what is our Vx? Vx is V cos theta times t. This time which we are talking about, it is the time it was in air. Meaning we are talking about this time here. So I'm going to replace that t with this formula. So I'm going to say that the range is going to be V cos theta times the time is going to be 2 V sine theta divided by, we have G. Now from here I can do simple math. V times V is going to be V squared. Then I'm going to have 2 sine theta cos theta divided by G. So we have got an identity here. When you start trig, you are going to understand, by those who are doing ADMA, this is an identity. I can replace this with something else. I can replace this with what? Those who know, I can replace this with what?
Sine 2 feet.
Sine 2 theta.
Sine 2 feet.
So I'm going to replace the whole of this with sine 2 theta. Meaning, I'm going to say this. My range is going to be v squared sine 2 theta divided by g. So this is the formula for finding range in the second trajectory. This is the same formula. Okay, anyway, this is the formula for range in the second trajectory. Unless you have questions. Do you have questions? So in short, this is what you need to know under second trajectory. The third trajectory now. The third trajectory is a combination of the first trajectory and the second trajectory. So here is our diagram. You throw a ball from this point. Now it's going to be at an angle. From this point you project it there. Then it goes down. What you have to understand is that you are going to project this at an angle. You are going to project this at an angle. Let me just put it there. The angle theta. This part here is the first trajectory. The down part here is the second trajectory. Oh, sorry. This part here is the second trajectory. The down part here is the first trajectory. So the third trajectory is a combination of the first trajectory and the second trajectory. But here are the simple principles which you have to know. Okay? We are going to have the height of the building. This h you are going to be given always, guys. So here the horizontal distance is the range still. Now let's call this point A, point B, point C. The first question which you have to ask yourself is how high it was from this point all the way down here. What you need to do is that they are going to give you this h. What you have to do is just find this h, guys, from this point here all the way to there. Now, to find this h is to use the same formula. V squared sine squared theta over 2g. Once you get this, plus the h which you are going to be given here, that is the total distance which you are going to have. The maximum height. Does that make sense? Okay. That is the first thing. Now, to find the total time, now this is where now there's a bit trick. To find the total time, you need to find, you know how to find the time from A all the way to B. The time from A to B, we have said that it is V sine theta over G. Now, you need to get another formula which is going to help us to find the time from B all the way to C. From B to C, it is basically the free fall motion. This is going to be the initial velocity. So we're going to use the same formula where we're going to say h will be equal to v initial times t plus half gt squared. But what you have to understand is that the initial velocity is 0. This is going to be cancelled. You're going to have h will be equal to half gt squared. The h which we're talking about here, it is the total distance from this point all the way up to down here. You're going to discover that you're going to have, if I do times 2 everywhere here, I'm going to have 2h is going to be gt squared. We divide it by g, we divide it by g. So this h, let me put it as h max so that you should not be confused. So this h is h max, h max. So I'm going to have t squared will be equal to 2 times h max, everything divided by g. I get the square root, I'll have this. I know you can use that other formula, but that formula is, you can waste a lot of time actually. So when you add this time and this time, you are going to get how long it was in air. So this time is just the time from A all the way to B. This time is the time it was from B all the way to C. So when you add it, when you add those two times, then you are going to have how long it was in air. Now how do you find the range? To find the range, once you find the total time, so now let me just give you the general formula for total time. To find the total time, the t total in the third trajectory, this is the formula. V sine theta divided by g plus the square root of 2h max. This h is the h from this point all the way up to down here, divided by g. So that is going to be the total time. The same time which we are going to find here is the one which we are going to use to find the range. In this case, the range is going to be equal to the vx is going to be v cos theta times t. This t is the total. Unless you have questions. That is projectile motion. Yes, please ask. Questions? I'm inviting questions. Let's ask. Those having questions?
I wanted to ask for the value of G. I saw on the previous one, G, you going up, you said G is negative. So
Yes.
is it always negative going up and positive going down, or it changes?
Uh, where it's going to change, I'm going to tell you, especially when it's coming down. There is one situation which is going to happen where g is going to be negative when coming down in only one scenario, and I'm going to show you. I've got a question.
Oh, all right.
Sure, you should just remind me before the end of this lecture. So now, there's also a question which they like asking to say, find the velocity just before it hit the ground. To find that velocity just before it hit the ground, what you have to understand is this. You are going to have the Vx which we are saying is V cos theta. That Vx which you are going to have, you need to find the Vy. To find the Vy, you are going to use this formula. Always. Vx you just do direct. Vx is equal to V cos theta. But to find the Vy, you are going to use this formula. Vy plus, but you are going to use g as negative because when it was going up there it was negative, so you are going to find that this is going to give you uh, half, sorry, gt. So once you use this formula, this is going to be v final, this is going to be v sine theta minus gt. So you know that the initial velocity, this is what you have been given already. Just plug in the values and find. After finding this is your Vy now. So we're going to say that the velocity just before it hit the ground, you use this formula. You get the Vx which you have found there squared plus the Vy squared. Once you get this velocity, that is the velocity just before it hit the ground. Does that make sense? Now, the time which you are going to get here, it is the time it was in air. The total time, that is going to be the time here. Yes, ask questions.
Sir, how about in a situation whereby probably they are specified to say finds
The vertical component.
yes, just before it hit, just
Find the
just
vertical.
before it hits the ground,
Uh-huh.
they specify to say as a y component, then
Yes,
not including the
yes.
z.
So as a y component, you are just finding this only and leave it. So the answer they are going. If sometimes when they ask you to say the magnitude, you just get. If it's negative, just ignore the negative because you are finding the magnitude. So when they say the vertical component, they're talking about the y-axis. Just get that y. As simple as that. Is that okay?
Yes, sir.
Thank you. So from here now, I've got few questions which I want us to do here. Let's start with this question. Let me just get a calculator. Do you have people who have got calculators? So we're going to do fast for the sake of time. Time is not with us. So now, the first question is saying, the first question is saying, a young boy shoots a stone from a catapult at a speed of 15 meters per second. The catapult is pointed 40 degrees above the horizontal. Part 1. How far horizontally from the catapult does the stone travel when it falls to the same level as the catapult? What are they asking?
Time. The time.
How far, guys? I say they're asking about horizontally. What are we talking about?
The distance
Which distance?
in the horizontal
The
direction.
range. In short, just say the
The
range.
range.
Yes, the range.
Yes.
Now, first you need to come up with a free body diagram. So here is going to be our free body diagram. Here is our catapult. Okay, that is going to be the angle here is 40 what? 40 degrees. Here is our range. Can you mute your mic? I want to find how far it was. Remember what was our formula for range? Those who can remember, we are from driving this formula, guys. This is the second trajectory. The formula for range, tell me. You've forgotten? Hmm? The formula for range.
I think v squared sine squared theta over 2
No. This is where we talked about this.
V squared sine 2 theta over G.
Over G, yes. So the range is going to be, our V is 15. We square it. When they say sine 2 theta, it's the angle you need to double it just. So the angle meaning 2 times the angle which is 40. Meaning the angle is going to be what now? The G is always positive when you use these formulas. So the angle meaning the angle which you are going to use here is the same as saying 15 squared sine 80 over 9.8. What are you finding? So 15 squared sine 80. I divide it by 9.8. I'm getting 22.61. 22.61 is our answer in this case. Next question is saying, how long does the stone take to reach this level? How long it was in air? That is this question. So what was the formula for finding time? From this point all the way up to down here. We talked about this. The hmm? Come on, come on, come on, come on. I said this was A, this is B, this is C. Now they want the time from A all the way to C. What was that formula? Do fast, do fast, do fast.
2 V sine theta.
2V sine theta divided by what? G. So our 2 times V is 15. Then we have sine 40. You have got a question you can ask? Those having questions you can ask. So 2 times 15 is 30. So it's the same as just saying 30 sine 40. 30 sine 40 divided by 9.8. I'm getting 1.967, which is just the same as 2.0 seconds. If you want, you can say the time is 1.98 seconds. So that's how long it was in air. Unless if you have got questions, you can ask before we go to the next question. Here's my next question. An anchor standing on a cliff for 5 meters, like I said, they are going to give you this H always. So here is our range. So they're saying an anchor standing on a cliff 45 meters above the level field below shoots an arrow at an angle of 30 degrees. the horizontal with the speed of 80 meters per second. This trajectory, is it the first trajectory, the second, or the third?
First projectile.
The first. This is the
Third.
third, yes, this is the third trajectory. Yes, thank you. Now, the first question is saying, what is the maximum height the arrow arises to with respect to the level field? What are they asking? What are they asking? The maximum height. I said, this is the same as just saying it is coming from there. Again, it goes there at an angle, then it reaches there. What did I say for us to find the maximum height? They want the height from this point all the way up to down. I mentioned to say this edge of the building, they are going to give you always, like you have seen here, this 48 they have given us. What else are we supposed to do for us to find the total height in this case? Let's do fast. Let's do fast. Let's do fast. What did I say? Hmm. I said you need to find the maximum height for the second trajectory. To find the maximum height from this point all the way to this maximum height here. Once you get that h, add it to this 48. That is going to be the maximum height. So you use this formula, v squared sine squared theta divided by what? Divided by 2g. Once you get this h, add it to 48. That is going to be the maximum height. Okay? Always when they ask you about the maximum height in the third trajectory, use this formula to find this h here. Then you need to add it to this one for you to find the maximum height. So now to make things simple, this formula you can just write it in this way. It is the same as just saying h will be equal to v sine theta, then you square it divided by 2g. Let's plug in the values. So my v is 80, sorry. Sine the angle is what's the angle? 30. Then we square it. Then we divide it by 2 times 9.8. So those having calculators, you can help us. What are you finding? So you are going to say first 80 sine 80 sine 30. Then the answer which you are going to find, just square. So it's 1600. So 1600, 2 times 9.8 is 19.6. You divide it by 19.6. I'm getting 81.63 meters. So I need to add this with this. So my h max is going to be equal to the 48 plus 81.63. So what will be my h max in this case? Does that make sense? Unless you have got questions, you can ask, please. So I'm getting 129.63 meters. As simple as that. Any questions? We continue. We continue. I'm waiting for the response.
Yes.
Okay. The second question is saying, how far from the base of the cliff will the arrow land? What are they asking?
The range.
The range. Now allow me to put this h max here. H max we have said is 129.63. So let me create space. So what is the formula for range? The third trajectory. What did we say?
V naught sine theta times time.
V cos theta times time. This t is the total time I talked about. I said this total time is given by, those who can remember, what did I say? I said this time is given by v sine theta divided by g plus the square root of 2h max, everything divided by g. That is going to be the time which we are talking about here. This time, how long it was in air. So this question they just ask about how far from the base, but they need to say you are supposed first to find the time. You can't run away from time. So we're going to find time now. In this case, we're going to say this t is going to be equal to v is 80 sine 30 divided by 9.8 plus the square root of 2. This h is the h max, which is 129.63. Everything divided by 9.8. Let's find this separate and this one separate, then we add them. As simple as that. So we have, this is 80 and not 8. So we have 80 sine 30. The answer I find divided by 9.8, which is 4. I'm getting a 4.08 plus, what is 2 times inside there? 129.68. The answer I find divided by 9.8, then I get the square root. So I'm finding 5.144. So I'll just put 14. So I need to add these two. If I add 4.08 plus 5.14, I'm getting 9.22. So 9.22 seconds, this is my time. This is the time which I'm going to plug in here now. So to find the range, I'm going to say my range will be equal to, the V is 80 cos the 30 degrees times the time, which is 9.22. So what will be my range? So we have 80 cos what? Cos 30. The answer I find times 9.22. So I'm getting my range to be 638.78 meters. As simple as that. Unless you have questions. Do you have questions? Those having questions, please ask. Yes, yes. Um, s- Sorry, I'm not getting you. What are you saying? Uh-huh. How do you tell that this is the first trajectory? Okay. For you to know that this is the first trajectory, this they are going to tell you to say the ball is released from the top of the building. Okay. For example, if you see this is the first trajectory. If you see this, a ball, it was projected at an angle from the level ground. That is the second trajectory. The ball is projected at an angle from the building. That is the third trajectory. So this is the first trajectory, the second trajectory, the third trajectory. Do you stations? So I want someone to take a screenshot of this question. Take a screenshot of this question. Send it in the group. I want you to solve this question. This is the same question we are from solving. I want you to find the answers and send me the answers in the group. So take a screenshot. Someone to take a screenshot. Is that okay? You have done that. Okay, now we have got another interesting question here. This is question 9 from 1015 total sheet. A projectile's launch speed is 5 times its speed at maximum height. Find the launch angle. What does it mean? So let's assume to say you are projecting something at an angle. So from this point here all the way to somewhere here, okay? Now they are saying that you have the angle. Let's call this angle to be theta. You are projecting this at an angle. Remember, you're going to project it with an initial speed. I mentioned to say the initial speed, the velocity in x direction doesn't change, meaning that the speed which you are going here at the maximum height, if this is the maximum height, h max, meaning that you are going to have two velocities, the velocity in x direction which doesn't change and the velocity in y direction which is going to be 0. So at maximum height the vy is 0, but the vx you are going to have the same, which doesn't change. So they are telling you to say the velocity which you have here at this point is going to be 5 times at its maximum height, meaning that this velocity which you have here at this point here, we know that the velocity is always this, the vx initial, the vx is going to be equal to the v initial cos theta. So they are saying that the velocity which you have at first here is going to be 5 times at its maximum height, meaning that at this point the initial velocity which we had, that velocity, this velocity is going to be 5 times v cos theta. Okay, 5 times, we need just, when they say 5 times, just get that number 5 times what you have. So if it was maybe 3.5, we would have said v initial will be equal to 5, maybe 3.5 v initial cos theta, just like that. They want us to find the angle. Okay, so we have v initial is equal to the 5 v initial cos theta. We want to find the angle. We can divide both sides by v initial, even here v initial. As we can see, these two can go, these two can also go. We are going to remain with 1 on the left hand side. We are going to have 1 will be equal to 5 cos theta. I can divide both sides by 5. I can divide both sides by 5. I can see that cos theta will be equal to 1 over 5. At this point, what can I do? I can divide both sides by cos. Once I divide by cos, it's the same as just saying theta is equal to cos inverse. Then I have got 1 over 5. Meaning it was projected at an angle of, I'll get my calculator, shift cos, open brackets, 1 divided by 5. I close the brackets. It was projected at an angle of 78.5 degrees. As simple as that. Unless you have questions. The velocity in x direction doesn't change. So if it doesn't change, meaning that at the maximum height, the initial velocity is going to be 5 times at the maximum height. So we're going to have the v initial is equal to v times, or 5 times v initial cos theta. Divide both sides by v initial. V initial, we're going to have 1 over 5 this side. Then you're going to have cos inverse, open brackets, which is going to be theta is equal to cos inverse 1 over 5. So the angle which is supposed to be projected at is going to be 78.5 degrees. Unless you have questions.
So why haven't you used the sign since it's like it's going up?
Okay, we haven't used sine because at maximum height, the final velocity at that point, at maximum height, the velocity in y direction at that point is 0 at maximum height. We are using sine in y axis, but we are saying that in x axis at this point the velocity in x direction doesn't change. That's the reason why we are using the velocity in x direction, because we're talking about the maximum height. We can't use sine because in y direction at that point it's going to be 0. Does that make sense? When an object reaches at the maximum height, the velocity at that point in y direction is 0. But the velocity in x direction doesn't change. The velocity you are going to have at first is going to be the same velocity you are going to have at the maximum height. It's going to be the same velocity you are going to have at the last point here. But they're telling us to say the initial velocity which we had, since it's going to be the same constant, but they're telling us to say at maximum height, its initial is supposed to be 5 times. That's why I've come up with this formula.
Oh, I get it now.
Sure. Okay? It's making sense, right?
Yes.
Okay.
Yes.
So if it's making sense, I have another interesting question here. So this I think is going to be the last one. We also have this. Okay, let's solve all of them here. So I've got in the figure shown below, a stone is projected at a cliff of height h, which is the small h, with an initial speed of 42 meters per second, directed at an angle 60 degrees above the horizontal. The stone strike at A 5.50 seconds after launching. Part A, find the height h of the cliff. Part B, the speed of the stone just before the impact at A. Part C, the maximum height h reached by the ground or above the ground. Now, it is very very important, this point here, they are saying that the time it took for it to reach at point A from this point all the way to point A, it was 5.50 seconds. But we know the formula which can help us to find the time from let me call this point let me call this point x, and then this point y, or let's say this is x, this is z. We know that the formula which we can use to find the time from this x all the way to z. Tell me the formula. It's going to be v sine theta over g. Once I find that time, meaning I can know the time it's going to take for it to, the time it used to move from z all the way to a. Once I know that time, I can find now the h, this h from this point all the way to z there. Once I find that one, I'm going to find the fine of the maximum height. I'm going to do minus, then I'm going to find this h. Okay, let's find first the time from x all the way to z. So it's going to be the v is 42. So sine what? Sine 60 divided by g, which is 9.8. Those having calculators, you can help me. We have 42 sine 60, which is going to be 36.373. I divided by 9.8. So I'm getting 3.71 seconds. This is the time it took for it to reach at point Z, at this point, at maximum height. Knowing that, we can now know the time it took from Z all the way to A. We are going to say the total time is 5.5. I'm going to say 5.5 minus 3.71. So meaning that the time from Z all the way to A is going to be equal to, I'm going to say 5.50 minus 3.71, which is going to give me 1.79 seconds. Now from here, I want to find this small h, but I can first find the time, the h from this point all the way to this point. Let's denote this one as just y. Once I find this, I'm going to find the maximum height reached by the ball. Once I find that maximum height as y, that will be my h. Once I find that maximum height, is going to help me to find also part C. Does that make sense? Now, we're going to say, at this point, we're going to say, let's find that h. To find that h, we know that at this point, the initial velocity is going to be 0. We don't know the final velocity. Which formula can we use? To find h, we can use this. I'm going to use y here because I want to find y, but it's a distance. V initial times t plus half gt squared. So my y is going to be, this is 0. I'm going to cancel it, half gt squared. Let's plug in the values. Half g is coming down is 9.8. T is going to be the time from this point here all the way to A, which is 1.79. I square it. Plug in the values we see. We're going to have 1 over 2 is 0.5 times 9.8 times 1 point times 1 point what? 1.79. I square it. So I'm getting my y, this y, to be 15.7 meters. That is the distance for y. Now, if I find this, I can find what? The maximum height now. Once I find the maximum height, how do we find the maximum height? Remember, the maximum height is given by the formula this. V sine theta divided by g, 2g, but we have to square this. Once I find this, I'm going to do minus this. That will be my h now, the small h. Okay? So V is 42. Sine the angle is 60. We square it over 2 times 9.8. So what will be our h in this case? Let's see. So I have 42 sine 60. The answer I find, I square it. I divide it by 2 times 9.8 is 19.6. So I'm getting 67.5. Now, this answer which we have just come up with here is the answer for part C. We are done with part C. Now, to go back to part A, I'm going to say the answer which I've found here minus this. Okay? So to find the small h, this is what I'm going to do. I'm going to say the small h is going to be given by the capital H minus y. So the capital H is 67.5 minus 15.7. So my h is going to be 67.5 minus 15.7, which is going to be 1.8 meters. So that is the small h. So for part A and C, we are done. Unless you have questions before we go to part B, the last one. Do you have questions? Okay, so if you don't have questions, the question B is saying the speed of the stone just before the impact. This is what I was telling you. It's just a matter of us finding the Vx and Vy. That's all. Vx is always V cos theta. Then Vy we're going to find using that formula. So the Vx is going to be V cos theta. So Vx is going to be, the velocity is 42 cos 60. So our Vx is going to be 42 cos 60. I'm 1 meters per second. That is my Vx. I need to find the Vy. To find the Vy, you always use this formula. Vy initial plus gt. But g, since it's going up, is going to be negative. Therefore, we are going to have this. This is going to be V sine theta minus gt. Because g is negative now. So V final y is going to be, V is what? Is 42 sine 60 minus g is 9.8. The time it took from this point all the way to point A, we have been given, but it's 5.5. Let's see. So our V final is going to be 42 sine 60. I'm getting 0.37 minus, what is 9.8 times 5.50? 3. Let's do minus. This is going to give us negative always, just because it is coming down. The velocity now at that point is supposed to be negative. So 0.53 meters per second. Now, this is vertical, the vertical velocity, and this horizontal velocity. To find the velocity formula now, the square root of Vx squared plus y squared. Let's plug. So we are going to see that if I get my calculator, 21 squared plus, I will ignore the negative because it's in the square root and then we are squaring it. So it's going to be 17.53. I square it, I get the square root. So I'm getting my answer to be 27.355, which is the same as 6 now, meter per second. So I'll say 5 meters per second. So I can say that the final answer is 27.36 meters per second. As simple as that. So that is it for today, and projectile motion, I can confirm to say we are done unless you have got questions.